Hey, am I audible to everyone? And is my screen visible? Great. So we'll be starting in another 2 minutes. Just waiting for others to join. All right, guys, let's get started. So today we are planning to quickly wrap up with MapReduce in the first half an hour, and then we will start with Pig. So yesterday, we saw some MapReduce codes. We saw about combiners. We saw about what happens if we increase the number of reducers. We looked at a demo. Then we looked at partitioners. So today we will be looking how to test the MapReduce code. So that's basically unit testing. So in actual scenarios, unit testing is also a part of developers. To be frank, guys, so as mentioned that nowadays no one actually codes in Java. So no one actually writes unit test cases in Java nowadays. But still it's better to know how to write it in case if you're working with Java. So I'll take a very simple example. So MR unit is very simple. So what is MR unit? Basically, it's an API which is developed by Apache itself, and it provides you a, a way of writing test cases to test your mapper and reducer. It runs integrated with your JUnit testing. Okay, and just to specify what is JUnit, so JUnit is a platform where you can run test cases in Java. So I'll just move on to the demo. It's very simple. Okay, you can write a test case in a single line. So I'll be doing it for word count. So we are clear with the word count logic, right? Let's say this is my map method, which is reading the input one by one. It is tokenizing it based on spaces, and then it is outputting it. Now, if I write a test case for this, okay, so what I've done is, for writing a test case, I've created a Java class. Inside this class, So I have added the JUnit jars in my build path. So this JUnit is available and this MRUnit API is also available to my code. Okay, so for writing test cases, this is a standard procedure. Okay, you have to create a class and you have to create multiple methods. These methods would actually be your test cases. For every method, so let's say I've written a method test map driver. So your JUnit, it considers this particular method as a test case when you add this @test above the method. So if you see, if you see the statements, this test is coming from this JUnit. So what I'll do is, so for testing, see for unit testing, this is a standard thing in unit testing. For writing unit test cases, you actually don't execute your mapper or reducer. So let's say you're writing a unit test case. Let's forget about map reduce. Let's say you're writing a unit test case for your application which connects to a database. So in actual unit testing, your code, your unit test should never go and connect to the database. So we usually mock. So what we do is, so there are multiple types of testing, right? In unit testing, it will be written in such a way that you test the flow of the code without connecting to external objects. For example, if you are writing a unit test case for a database check, you will never go and actually connect to a database in your unit test case. Similarly, if you're writing a unit test case for map or reduce, you will never go and execute a mapper or reducer. So what you will do is, you will basically create a situation in your test case itself that you're passing this particular set of input to your mapper, and you are expecting that the mapper should output me this particular thing. So you are setting your expectations also. So with the input, you are telling your mapper that this is the output. You're telling your test case that this is the output which I am expecting. If it gives the same output as per your algorithm, which you have written in the mapper or the reducer, the test case is successful. If it does not, test case fails. So for writing a test case, it's actually a single line code. So let's say I'm writing a test case for my mapper. So what my mapper is doing, what is the input to my mapper? It's a string, right? It's a string which contains multiple spaces. And what my mapper is doing, it is breaking the string on the basis of a space into multiple words. It is sending out the word as the key and constant 1 as the value. So this piece I need to test. Like this particular logic which I have written in my mapper, is it performing the same way as expected or not? So MRUnit, for testing mapper and reducer, it has specific classes. So for testing mapper, it has something called as map driver. For testing reducer, it has something called as reduce driver. So I'm testing this functionality of my mapper. So what I have done, I have created my input, which I would be providing to my mapper. I know that this input will result into high, 1, high, 1, this, 1, is, 1, is, 1, and is, 1. So when you're writing test case, you are providing the input also and output also. So how do you write a unit test case for MRUnit? I instantiate map driver. Okay, this arguments of map driver would be same as the arguments of your mapper. To this map driver, so there are multiple methods. It has a method called as with mapper. So you are providing which mapper you are testing. So this with mapper method accepts a mapper. So this is the mapper which you are testing, for which you are writing a test case. So with mapper, I have provided my mapper. I'm passing some input to this mapper. So with input, this particular input, which I have already defined here, this particular input. And then you have to specify what is the output. So output is how many times? 1, 2, 3, 4, 5, 6. It will output 6 keys and values. So I'm writing with output 6 times. So I'm saying with output text hi 1, this 1, and is 1 3 times. And I ultimately say dot run test. So if you notice, these are not multiple lines. It's actually a single line. Eclipse has wrapped the text, but it's actually a single line of code to write a test case on your mapper. Any doubts in this particular map driver thing? Great. Same thing goes with your reducer. So to my reducer, if I want to test my reducer, I know what is the input my reducer takes. So it takes a key and it takes a list of values. My reducer for word count, I have designed it in such a way that whatever list of values it is getting, it should sum up the list. Correct? This is the word count algorithm which we have coded and we have executed. So let's test this. Okay, so without running the mapper and reducer on an actual Hadoop cluster, we have to test this. So similarly, as a map driver, we have a reduce driver. It is also a single line of code. So input to my reduce would be a key and list of values. So it's same thing. I'm representing it here. So I say new reduce driver. These types should be same like your reduce types, reducer types. Same like mapper, you're passing which reducer you're running test case on. So you're passing your word count reducer. You're passing your key. So you're passing with input key. I'm passing a key to it. And I'm passing list of values. So remember, reducer takes a key and list of values. So I'm passing the key and I'm passing the list of values. So what I've done is I've created a list this way. So I'm passing 4 values, 1, 1, 20, and 1. At the end, I should expect that my reducer should sum up these values. So it should give me 20 plus 1 plus 1 plus 1. It should give me 23. So I'm specifying that it should give me an output, Hardeep, and 23. So this is how I write a test case for my reducer. It's again, this is a single line of code. It's just wrapped around. Now for running test cases, so it will run with JUnit. So if you notice, there is no main method here. So this is usually what happens in a test case. So you can write as many methods you want to create test cases for. You can, so each method corresponds to a test case. And remember, the signature of these methods is constant. It should not return anything and it should not take any argument. This is a fixed signature of a test case. And at every test case, you write this @test. All right. So in this file, there are 2 test cases. This @test makes your JUnit know that I need to run this methods as test case. So if you notice, there is no main method here because I'm not running this as a Java application. I'm running this as a JUnit test case application. So if I just right click and if I select run as, so see, I'm getting an option JUnit test case. I'm not getting any option run as Java application because there is no main method here. Yes, so Manish has a question. You're doing it in single class. Yes, Manish, I'm doing it in single class. So test case is a single class which has multiple methods as test cases. So ideally it should be single. So let's say you're testing one class, and for testing one class, you have inside that class you have 10 methods. So you won't create 10 different classes as test cases. You will create one class which would be your test case class. Inside that you will be creating as many number of methods you want as test case. Okay, so if I just run this, I say run as JUnit test. So if my test case is successful, it will give me a green signal. Otherwise, it will mark something in red. Okay. So if you see it's green, so it ran two test cases. Both the test cases are successful. Okay, both the test cases are successful. The first test case, this map driver test case took around a second, and this second one took around 4.5 seconds. Okay, so Manish has a question. Can you run it step by step like debugger? Yes, Manish, I can. So what should be done in that case is, so you can add debug points anywhere in your code, and instead of run as JUnit, you can select debug as JUnit. So it will run in debug mode. Yeah, so Rahul has a question. This is not running inside Hadoop. So can we run this on Windows? Yes, Rahul, we can. So it's actually running on your Linux itself, sorry, on your Eclipse itself. So it doesn't matter it's Windows or Hadoop or Linux. You can run it anywhere. Right, Manish? So this is my debug mode. So now I can run this line by line. Okay, if I keep on pressing F6, it will run it line by line, and I can check my input, what is changing. Right? Just like a normal, any Java method, any Java application. Right? I'll just press F8, so it will execute everything at once. Done. Okay, okay. So Manish says he does not know Java, that's why. Okay. Yes, Manish. So this is a functionality your Eclipse provides you. You can put in the breakpoints and you can debug. Just like so if you know Python, it's just like PyCharm. Okay. So if you want to play with this, so let's say I give some input and I just tweak my output to be a wrong. So let's say I just make this high to a small h. Now this first test case should fail because it was expecting capital H, and my second test case would succeed. So if I run this again, okay, so my test reducer is successful and it's giving me a proper error that what it is expecting and what it got. So it was expecting high comma 1, it got small high comma 1. Right? So it gives you a proper position also. And if you check the JUnit console, where is that console miss gone? I'll just see. I'll just run it again. So So here it is. It's giving me a red mark for this map driver along with what is the error. Right? So you can, so this will say that this particular test case has failed. You can, likewise, you can write test cases. It's very simple. It's just a single line of code to write a test case. All right. So let's move on to distributed cache. Oh, so before that we have counters. All right. So remember yesterday I told you in MapReduce, when you run the MapReduce job, you see multiple counters. So yesterday remember we were looking at reduce shuffle bytes as a counter to test like my combiners is reducing network usage or not. So those are counters. So yesterday I had mentioned there are two types of counters. Okay, one is a system counter and the other is user defined counters. So let's say I'm writing a word count example. All right, let's say I'm writing a word count example, and so the same logic which I'm writing, right? Counting every word. Let's say additionally, okay, additionally, instead of counting word counts, I want to count the total number of lines in my file. Okay, get the problem statement clear. So I am doing a word count that I want in the output as it is. But additionally, I want to do some extra processing. I want to count how many total number of lines are there in my file. So in such scenarios, so if you want to do it using MapReduce, this is not possible. In a same MapReduce code, you cannot club two types of processing together. So if my MapReduce code is designed for doing a word count, the same MapReduce code cannot be reused for doing a line count also. Okay, so in such cases, you can take advantages of counters. Now, what are counters basically? It counts events in your code. Okay, it counts some events. So it can be used at multiple places. Okay, just an example. So this is one example. So along with word count, you want to do some extra processing also. For example, line count. This can be one place. Let's say you're writing a MapReduce code and you want to write some debug statements. All right. See, usually developers have a habit of writing some print statements in between your codes to check if your code is running in the right order or not. So what we do is we usually put some print statements or debug statements, log statements, correct? Now, if you see, if you run a MapReduce job, MapReduce creates a lots of logs. Okay, at the end of MapReduce, there are lots of logs generated. So if you want to check if your particular print statement was called or not, you have to browse through the entire file of log which your Hadoop is printing. Okay. Additionally, if you want to count how many number of times your single debug the log statement which you have written, how many number of times that is called, it becomes a lot of work to do, right? So in such cases, in such scenarios where you are tempted to put a log message, right? Always try and use counters. Now so using counters is very simple. Okay. Advantages of counter is you get a value. Okay, you get the number how many times a particular event occurred. And the best part is across your entire application. So counter is basically, it's a global state your MapReduce maintains across all your jobs. Sorry, not across all your jobs, across all your tasks of a single job. So let's say you're writing a mapper. Okay, that mapper is running, let's say 10 times. For a single mapper class, it created 10 mappers and let's say 10 reducers. Across this mappers and reducers, if you want to count a event, all right, so this counter is global across these tasks. A typical use case can be, so let's say you have a file, right, which you have words separated by comma. right? It is a CSV file, right? Let's say this is employee ID, this is department ID, this is gender, and this is salary. Okay, this particular format of file is, let's say it's of 10 GB. What you have done is you have written some piece of code for processing this particular file. So what I've done is I have used my string.split method, and I'm accessing this indexes of my string split array, correct? Now let's say for some days or so for some months, the data was coming in the same format. Suddenly, okay, suddenly for let's say from a particular month onwards, this format has changed, right? So instead of getting department ID as a second column, I get department ID as the fourth column. Let's say these two places are swapped. Will this piece of code which you have written still suffice? Will it run as expected? No, it will start throwing errors, right? Now, if you're getting any error, so let's say I got one more file, 1 GB file in which the data is swapped. So total, let's say I have 11 GB of data, out of which 10 GB is the old format for which my code is running properly, and 1 GB is a corrupted format. All right, but I want to process this file. I want to process this entire 11 GBs. Okay, your piece of code, if you're running it for 10 GB, that will run fine. But if you're running it for this piece, it will start giving you errors, some array index out of bound or some error related to your logic. What you can do in such cases is, instead of exiting code, you can write your piece of code inside a try catch. You can handle this exception. And whenever you're getting any exception in this piece of code while processing this file, this particular 1 GB, you can create a counter and increment that value. So what advantage you're getting here is you're still processing the entire data. All right, at the end, so I will never be able to process this 1 GB because the data is wrong. Okay, the fields have been swapped. But at the end, this 10 GB would be processed, and I would be having a counter which will say me how many records were left unprocessed. Right? So there are many use cases like these where you can use a counter. Right? Now using a counter is very simple. So there are two ways in which you can use a counter. Right? The first way is yeah, so Minesh says you mean error row counter, right? Yes, Minesh. So you can create any counter. So I can create multiple counters, and a counter for what purpose I need to use, that depends on my logic. So the logic which I've mentioned earlier, the error number of rows, that counter I'm using to count error rows. But I can count any other things also. Okay, for example, I want to count how many total number of records are there. Or let's say, I give you one more example. So same data I have employee ID, department ID, gender, and salary. All right. I am writing a MapReduce job for this to get total salary per department. So if I want to write a query for this, I will write department ID, sum of salary from this table, group by department ID, correct? This is the query to have sum of salary per department. Now, apart from this logic, let's say I want to add some more logic. Okay, I want to count, right? I want to count how many number of males and how many number of females are there in this file along with this particular logic. Okay, so what the problem statement is, my final output which I want is sum of salary per department, right? Irrespective of the gender. The second problem statement is, along with this output, I also want to count how many total number of males and how many total number of females are there in this entire file. Okay, can anyone tell me, can these two types of processing be clubbed in a same MapReduce job? Can you club these two processing in same MapReduce job? So Minesh says yes, Rahul says no. So Minesh, how will you club this? So listen to this. So in case of first processing, sum of salary per department, right? If you are working at your mapper and reducer level, so in mappers, what key value you will keep? So as key, you will be keeping your department ID. As value, you will be keeping your salary. Correct? In the second use case, I want to count number of males and females. So I'm changing my key, right? Now for doing this particular processing, my key should be gender and value should be a constant 1, same like your word count. So my key is changing. I cannot have a map reduce job in which for some scenario it is the key is department ID, for some scenario it is gender. I cannot have it that way. Okay, so for this cases, if you want to do these two processing, you would be writing two different map reduce jobs. One for doing this particular sum of salary per department and one for counting males and females. Now let's say I want to club this together. So this is a right candidate where you can use counters. Okay, so Minesh says, what if I want to count total number of employees? That is also possible. Okay, that is also possible, but still you cannot club it in a same map reduce job. You would have a different map reduce job for counting total number of employees. Right? So such scenarios where you want some extra processing on your input file without changing the output, you are counting some extra statistics in your data. For such cases, you can use counters. Right now, using counters is very simple. So remember, so if you're using counter, few things to remember about counter. Your final output will not be changed. So I would be writing a map reduce job to calculate sum of salary per department. I would be writing a counter for males and female count. All right. In my final output would still be this sum of salary per department. The male count and the female count would never be reflected in the final output. So when I say final output, I'm talking about the part files. So remember the part R000, part R0001, those files, which is the actual output of my map reduce job, this counts won't be reflected there. So my output will be same. All right, where I will see the value of counters, these would be in the logs. So when you run a map reduce job, at the end you get logs, right? At the end you get counters this way. This way, right? So here your output of that particular counter would be printed. Right? So this counter value is not stored anywhere. It's just stored in the logs. Right? Your final output is still the same. With the counter, without a counter, does not matter. Final output would be same. Let's look at an example. Okay. I'll be doing a very simple example. I'll be playing with the word count example itself. So in my word count, let's say along with my words, I want to count how many lines are there in my file. Right? I also want to count additionally how many lines are there inside my file. So what I'll be doing is for counters. So there are two ways to implement a counter. Okay. The first way is You have to define a constant string, right? You have to define a constant string. Okay, now where do you define constants in Java? Where do you define constants in Java? Uh, no, Manish, not inside a method. So you can define inside a method also, but it should be available to everyone. Okay, it should be a global constant. So the right answer is, in Java there is something called as enum. Right? In Java there is a thing called as enum. So we define constants inside an enum. So what I'll do is I'll create an enum. So I'll say new enum. Right? I'll name this enum as, let's say, EMP counters. Right? Inside this EMP counters, I create a counter, let's say line counter. Right? Now always remember, when you're defining a counter, right? When you're defining a counter, there are two things which you need to define. The first thing is called as a counter group, and the second thing is actual counter. Right? So basically, when you're using counters, all the counters should have a category. So if you look at an example, so if you look at this, I'll just use a highlighter. So if you look at this, the category here is file system counters. And inside this category, I have multiple counters. Right? So this category is called as your counter group. And inside this group, I have multiple counters. Similarly, there is a category job counters in which you would be having multiple counters. So your counters have a category, and inside that category, I can have multiple counters. So if you're defining a user-defined counter, the enum name, the enum name, in my case EMP counter, this becomes the counter group. And the fields inside this enum becomes your actual counter. So I can have multiple counters here. Okay, counter 1, counter 2, and so on. Right? But in my case, I'm just doing line count, so I won't be using this other counters. Right? Now how will you use it? This is how you define a counter. Now you can use it anywhere. You can use it inside a mapper also, reducer also. So let's use it inside mapper. Okay. Now what would be the logic to count number of lines? Can anyone guess? What should be the logic to count number of lines? Okay, so Shiv Prasad says looping. Chaitanya says sum of values and increment the variable. Okay. Number log line breaks. Okay. So everyone is thinking too deep. The actual answer is there is no logic at all. Okay, there is no logic at all, because if you look in MapReduce, this map method is called once per line, right? Your framework, it is calling this map method once per line. So this logic is automatically implemented to us. We are not applying any specific logic. Getting it? The text input format, to be specific, inside the text input format you have a record reader, right? The record reader will actually call this map method once per line of your input block, input split. So what I will do here is, instead of adding any logic, I'll simply use a counter here. Right now, how do you use a counter? So it's with this context object. there is one method to invoke a counter. So it is context dot get counter. Okay, get counter. So see, there are two overloaded methods for get counter. Let's first one takes an enum, which is the one we are using. Right, the counter name is the enum name, which is my emp counters dot my counter name. So this is how you call a counter. Basically, you're calling an enum. So this is fixed Java way to call a enum. Right, your class enum name dot the field name. Then you have to say dot increment, and you have to provide a number here. Right, by how many times you want to increment this when this particular line is called. So I want to increment it once every time this line is called. Any doubts in this? So what this particular single line will do, this line would be called as many number of times as many lines I have in my file. Correct? Because this map method is called once per line. All right. So your counter, every time this map method is called, your counter is incremented. Okay, this is a way to increment counter. You can basically use any number here for incrementing, but for our use case, I want to count, right? I want to, and the count would be sequential. So I'm incrementing it by 1. Any doubts in this? Great. So this is how you use a counter. That's it. There is no additional thing to do. Right? There is no additional thing required. Alright, so Chaitanya says, how can you use system.out.println? So Chaitanya, you cannot print anything in MapReduce. So if you do a sysout, alright, if you run a MapReduce job, it won't be available on your terminal. Right, that system.out.println won't be available in your terminal. It would be available inside your resource manager's logs. So you have to go to your resource manager UI to check where it is getting printed. So that's very difficult piece. So never try to use a sysout, system.out.println. Always try to use a logger statement or a counter. And if you want to debug something, you can normally debug using your Eclipse itself. Right? You can debug using Eclipse itself. You can put a breakpoint here anywhere, and instead of running it on your cluster, you can run the main method locally itself. Right? That is also possible. Okay. So what I'll be doing is I'll be just packaging this. Okay, so I'll tell you the other way also, how to access counter. So in this way, what we are doing, we have written an enum. The other way of using a counter is you don't define an enum. Okay, you don't define an enum. You can simply use this overloaded methods. Okay, the get counters overloaded method, which takes two strings. The first string is the group name, second string is the counter name. So you can hard code the group name here itself. Let's say my counter. So this become your counter category, counter group. And here you can give the counter name. Okay, line counter or anything. You can say dot increment 1. So these are the two ways in which you can use counter. The first one is called as a static counter because you are statically defining the counters you would be using. So you have defined that you would be using line counter. So the first counter is called as static counter. The second counter is called as dynamic counter. You are not defining a counter, but you are using it at runtime. You are creating a counter using it on the fly. So the second type of counter is called as a dynamic counter. All right, so I'll be not using it. So I'll just create a jar out of this. Yes, Rahul. So Rahul has a question where we will give group name in case of enum. Is enum class name is group name? Yes, Rahul. The enum class name becomes the group name and the fields inside that enum becomes the counter name. So if your enum is defined inside a package, correct? So the counter group name will become package name dot enum name. So like you will see in my case, my package is count. So my group name would be count dot emp counters and my counter name would be line counter. Right? So I'll just build a jar out of this. So my jar is created. I would just copy the path of my jar. I should be having the command, previously used command. Okay, it's not there. I should know the file also. What's the input file? I think it's input. Right, I have deleted the word count input file. I'll create one more file then. I'm just copy pasting it. Right, so I am having 96 lines in my file. 95 lines, sorry. Okay, I'll place this file to my HDFS. And I'll run my MapReduce job on this Hadoop jar. The path to the jar. Oops. My main method, package name.class name, input, and output. So whatever output I would be getting inside this wout1 folder, that would be the word count output. But the number of lines which I have in my file, that's basically for which I have used a counter, that would be visible in the logs. Right, so let it run. Yeah, so Rahul has a question. Can we use Apache Logger in Hadoop? Yes, Rahul, we can. In fact, Hadoop also this loggers, the Hadoop logs which you are seeing, these are also Apache logs. So Hadoop itself is using those Apache logs. You can just create an instance of Logger and start using it. There is no additional thing you need to do. Okay, so here we got the output. Now if you see, here you go. So I have an employee counter. So if you see, my group name became the entire package name.enum name, and the number of lines I have is 95. Right? So this is how you will use counters, and you will retrieve counters. All right. Okay. So moving on. So yes, distributed cache. So as discussed yesterday, I already told you what is the use of this distributed cache. So in your code, if you're using some external APIs, you are developing a code on a single machine. But while running it, this jar of an external API should be available on all the node managers where your actual tasks would be created. Now, how it will be available to all the machines? Basically, for these reasons, your Hadoop has created something called as distributed cache. So what happens is, so there are a few commands to place a file inside this cache, right? So whatever you place inside this distributed cache, it becomes local to all your node managers, all right? So typical use cases, when you're using an external API, the external API's jar you place in the distributed cache, it would be available across the cluster, all right? And when the mappers or reducers would be scheduled on a specific node manager, that jar would be available to it locally. So it won't fail by saying class not found or some that kind of error. This is a typical use case. Okay, Chaitanya says, will it be at the resource manager? No, it won't be. Because resource manager is not executing anything, right? My mapper or reducer, it is not getting executed at the resource manager. It is executed by your node managers. All right. So this is one use case where you use distributed cache. The other use cases, so remember, yesterday I had discussed types of join in MapReduce. We have seen a demo of reduce side join. The other demo is your map side join. So what you do in map side join is, so just to reiterate what we discussed yesterday about map side join. So in map side join, there is one mandatory condition that when you're joining two files using MapReduce, one of the files should be very small. A typical use case, customer and transactions. Right? So let's say in my particular say warehouse, or let's say outlet, I have around 1,000 customers. Right? So this customer file would contain only 1,000 entries. So hardly it would be around 2 to 3 KB. All right, but these 1,000 customers can do millions and millions of transactions. So my transaction file can go up to GBs. All right, so this is a proper exact candidate, all right, a valid candidate for your map side join. So what do you do in map side join is, so remember in case of reduce side join, we were writing two mappers sending their output to a single reducer. Correct. Here what this maps reduce side join is very slow because 2 times shuffle and sort is happening. All right. In map side join, what you do is you distribute this small file to all your machines. That means this small file, in our case customer file, would be available to all your mappers locally. This customer file would be available to this mapper also, this customer file would be available to this mapper also. What you can do is you can do a local join. So you can write a mapper on your transaction file, right? You will be writing a mapper on your transaction file. Customer file would be available locally to that mapper. You can do a lookup to the customer file and do a join, right? You can do, so the actual join here is performed at your map side itself. That's why this is called as a map side join, which is very fast as compared to your reduce side join. The reason being, there is no network usage. There is no requirement of a reducer. You don't require a reducer in case of map side joins. Now, how do you achieve this map side join? How will you distribute this small file across the cluster? You can keep this small file to your distributed cache. That's a typical another use case of your distributed cache. So it can be used for placing external jar files, or it can be used for placing small files which could be further used for map side joins. Right? So got what is the use of a distributed cache? What is a distributed cache? So we'll just read through it. Distributed cache is a facility provided by MapReduce framework to cache files. These could be text files, archives, jar, etc., which could be needed by the applications. Files are copied only once per job and should not be modified by application or externally while the job is executing. So whatever you keep inside a distributed cache, it's basically read only, right? You cannot change it, all right? And till what time your files would be available in the cache? Until that MapReduce job is running. So if you are using a distributed cache, you are using it inside your MapReduce job itself. And when the MapReduce job finishes, the distributed cache automatically empties itself. So the span for which the file is placed inside that cache is very small, right? The lifetime is only until your MapReduce job is running. Right? Distributed cache can be used to distribute simple read-only data text files or complex types such as archives, jars, or etc. So Manish says, does it uses lot of memory? Yes, Manish, it depends on what size of data you are putting in the cache. Right? So ideally you should not put very huge files because cache is meant for keeping small things, right? Read-ready things. Right? So you should not keep very huge files inside the cache. It won't complain, it will accept, but it will, so it will basically it will not solve your purpose, right? If you keep a very huge file in the distributed cache, it will take a lot of time for your distributed cache to make that file local to all the machines. Let's say I have a 10 node cluster, I'm keeping a 1 GB file to the distributed cache. It will transfer that 1 GB to all the machines. Basically, it's using network worth 10 GBs. That will take a lot of time, right? So ideally small things, let's say my text file of, let's say 5 MB or 2 MB, right? Such small files, if I'm keeping the distributed cache, transferring it to 10 nodes would be fast. So you should not keep very huge files in the cache. Yes, so Manish has a question. Does cache gets cleared as soon as the job is completed? Yes, Manish. As soon as job completes, the distributed cache for that particular job is cleared. So let's say you have two MapReduce jobs. Both the MapReduce jobs require a same jar. In both the jobs, you have to place the jar again. Right? How do you place it? Again, there's a single command for that. Let's look at this. So what we'll do is we will look at an example of distributed cache along with this map side join. Right? So yesterday we saw an example of reduce side join. Today we will see an example of map side join. Okay. So the use case which I have is, so I have two files. What happened? I have two files. One file contains my Indian state-wise population. right? State-wise population. But the state which is mentioned inside that file, that's an abbreviation. Okay, it's not a proper state name, it's an abbreviation for the state. Okay, this is the file. Right, so for example, UP, it has a population. MA, it has a population. BI, population. So it has an abbreviation for the particular state and the population of that particular state. I have one more file which has an actual name of that abbreviation. Okay, so UP stands for Uttar Pradesh, MA stands for Maharashtra. So what I need to do is, in the final output, I want the actual name of the state and the population against it. So these are two different files, right? So typical use, so how will I do it? So I will create two tables if I want to do it in SQL. Right, I'll be creating two tables and I'll join these two tables based on the abbreviation, right? Abbreviation is the common column. So I can join based on abbreviation. Same thing, let's try to do it in MapReduce. And to be specific, map site join. So what I will be doing is, I'll be writing a mapper. I won't be using a reducer because I'm doing a map site join. I'm not doing a reduce site join. So I don't require a reducer. And I'll be writing a driver. Okay. Now let's look at the driver first today. Now driver is the thing which is executed first, right? Driver is the thing which orchestrates your MapReduce. Driver triggers your MapReduce, correct? So in the driver, what we are doing is, when we are creating an instance of job, at this time, I use a try catch block here and I place file inside my cache. Right? I place file inside my cache. So there's a statement. So this job class, it has a method called as add cache file. Right? Initially, this method name was different. It was distributed cache.add cache file, but that is now deprecated. Right? So the latest how you will use it is the job which you have created earlier dot add cache file, and you can pass the path of that cache file. Now this path is an HDFS path. So for running this cache file should be available at the slash location in my HDFS, this cache file. Right? So I'll be caching this file. Okay, so this statement is just adding to the distributed cache. Just a single statement to add. That's it. My remaining driver is as it is. So I'm setting my mapper, output key class, output value class, input path, output path, and I'm submitting my job. No difference. Just one-liner statement to add something to your cache. So this is very simple. Now, where we will use this cache file? Inside the mapper. Because we are doing a map site join, so we will be using it inside the mapper. So I will be writing a mapper on my actual input file, and for this abbreviation I would be referring my cache file which would be available to me locally from a distributed cache. Okay, everyone with me? Everyone following me? Am I going too fast? Yes, no, any answer? Am I going too fast? Everyone following me? Great, great. Thanks, Shiv. All right, Manish. So Manish says he does not understand Java but got the concept. The concept is the main point, Manish. That language is just a matter of syntax. If you Google, you will get the syntax. So syntax is not important. The concept is important. Okay. So what we'll be doing in distributed caches, again guys, this code hardly you will write it in Java. So Hive has a property which you set. Hive will automatically convert your join to a map site join. Hive will itself manage these things. So the frameworks is making your life simple, right? So hardly code at this level. Okay, but still you should know what your framework would be doing internally. Okay, so I'll be writing a MapReduce on this input file, and for this abbreviation I'll be referring to this cache file, and this cache file would be available to me locally. Right, so now let's look at the mapper. Okay, so if you look at the map method, what I'm doing is I'm getting my input line, that is this particular line. Let's copy paste it here. Okay, so I'll be getting this entire line inside this value. I'm converting it to string. I'm tokenizing it based on comma. All right, my abbreviation is this first thing, right? That's the token of 0, and my population is the second token. So what I've done is, if you look at the state, I'm trying to fetch it from a map. Now what is this map? So I've created a map above. So what I'm doing here is, so if you see, I have used a method setup. All right, now always remember, in MapReduce, let's say you want to do some particular processing only once. See, your map method would be called multiple times, right? Let's say I have 10 lines in my file, map method would be called 10 times. But if there is something which should be called only once, you should write those types of thing inside setup. So setup is a special method which is called once, and it is called before mapper. There is another method called as cleanup. That is also called only once, but the execution order is, it is called after map method. So the actual execution is setup, map, cleanup. All right. So what I'm doing in the setup method is, I'm getting cache files from my context. All right. I'm trying to get cache files from my job context. Chaitanya says like constructor. No, Chaitanya, it's not like a constructor. That's different. It's a method. It's not like a constructor. It's a method. Just the way it runs it is, setup method is called once. So let's say I have 10 lines. Let's say I have 10 lines. So my setup method would be called first. Then my map method would be called 10 times. Then my cleanup method would be called. So it's not like a constructor. It's different. Right? If you want to do some processing only once and you want to do it before the mapper, you should do it in the setup. If you want to do some processing after the map method, you can do it in the cleanup. Just an additional thing not mentioned anywhere, but I'll let you know what happens in the setup and cleanup by default. So in setup, if you're running a MapReduce job, in setup, the final output directory gets created. So in a MapReduce job, you specify the final output path, which should not exist. So in the setup, your final output directory gets created. So you will notice, if you're running a MapReduce job, and even if the job fails, still the output folder has been created. Okay, so when you will be running MapReduce job, you will notice this. Right? Even if your job is failing, even if there is any error in your code, still your final output directory would be created. The reason is, it is created before the map method that's in your setup. Okay, remember I told you, when my MapReduce job finishes, all the map output is automatically deleted. Correct? The temporary output of my mapper, it is automatically getting deleted. Where it is getting deleted, that is done by your cleanup method. That's a default implementation of your setup and cleanup. All right. I didn't get that, Rahul. So Rahul says cleaner or reducer setup. I didn't get that. Yeah, so Rahul says when we make reducer 0, mapper's output will not get deleted. Yes, Rahul. So if we make reducer 0, mapper output becomes the final output. So a mapper output goes to your HDFS. It does not get deleted. Right? So in that case, cleanup will do nothing. So this is already handled by your framework. Okay, it means when reducer setup is called, the file is deleted. No, Rahul, it's so see cleanup. So actual thing is when so your setup would be called first, then your map, the cleanup would be called at the end of your map reduce job. So your reducer also has a cleanup. Alright, so reducer task also has a setup and cleanup. So this would be there in your cleanup of your reducer. Right? Every task has a setup and cleanup, so it would be called inside your cleanup of your reducer. Okay, it's just good to know. All right, your framework takes care of it. Okay, so what I'm doing in my mapper here is, yes, Shiva, after map job is done. Okay, so what I'm doing in my mapper is, I'm getting the files from my cache. All right, I'm getting the files from my cache. This is a syntax. All right, get cache files from my context. All right, now I can place multiple files, right? Now I know I want to use the cache.txt file. Okay, I know I want to use the cache.txt file. So I'm applying a loop, right? And I'm checking if my path is equal to cache.txt, only then I'm doing the further processing. So what I would be doing is I would be breaking this cache file and I would be placing this inside a hash map. Okay, I would be creating a map, okay, a Java hash map from this particular file. Now the cache can contain many files. So when I say get cache files, so if you see it's files, it's plural. So that's why it's returning a array of the path, array of the URIs. All right. So I'm just looping it. All right. And if the path is equal to cache.txt, only then I'm reading this file. Okay. I'm breaking this file on the basis of a comma because this file is also comma delimited. I'm keeping this abbreviation as the key. Okay, now don't get confused. This is not my mapper key. Huh? This is the hash map, Java hash map, which I'm creating. Okay, I hope everyone knows what's a map. Okay, hash map. So I'm keeping this abbreviation as the key of your hash map and this state name as the value of my hash map. So if you look here, I'm splitting my line on the basis of a comma, right? I'm getting the abbreviation and the state name and I'm putting that inside my map. Right? And I have defined this map at a global level, at a class level. It's an instance variable. Okay, whatever you define at class level, this is called as instance variable. Okay, so this hash map is defined as an instance variable. So I can use this hash map inside my other methods also. So I'm using the same hash map inside my map method also. So what I'm doing here is, in my map method, what I'm doing, I'm breaking this, all right, and this UP, okay, this is there inside my hash map, right? And this UP is a key. So I'm just calling this UP. The map.get, and if you pass the key, it will give you the value. So in this state, I will get the actual value of this UP, which would be Uttar Pradesh. Right? And I'm simply outputting it from my map. So what I'm outputting, I'm writing the abbreviation as my key, And in the value I'm writing population, and I'm actually printing this population. Where I'm getting this population? From my input value itself, right? Which is actually read from this file, right? So I'm printing the population and the state. Okay, so here I have joined population with my state. Now this state I'm getting from my map, which is the hash map, and this hash map is getting populated from a cache file, which is there in my distributed cache. So here the actual join is happening. Okay, so Manish says, what if it doesn't find a value? So if it doesn't find a value, Manish, so in hash map, if you give a value, if it doesn't have it, it returns you null, right? So it will be, so if it doesn't have a value, so it would be printing here null. State will become null. Right? This thing will become null. It doesn't matter. So it's up to you how you're handling it in your application. Okay. So this is the mapper. Okay. Everyone is clear with the logic, what algorithm I'm using, where the actual join is happening. Actual join is happening here in my map method. Okay. So if I execute this, so I'll create a jar. I think it is already created. I already have a jar for this. Yes, map join. I have the input and cache file already placed to my Edureka's VM. Actually, I was facing a few challenges with this VM. I don't know. The data node was not working. Let me check. Yeah, it is working. It is working. So what I'll do is I'll put this input file to HDFS. No such file or directory. Okay. Okay, I think they have formatted Hadoop. Okay. So I'm placing this input file to my HDFS, and I'm also placing this cache file to my HDFS. Right, cache file I'm placing at slash location because in my code I'm trying to access this file from my root location slash, right? Okay, and I'll be running this. So Hadoop jar, the path of my jar, it's here itself, mr join, map join, I guess, yes. My main method, that is join driver. My input file, that's my user, sorry, that's Hardeep input.txt. My output file, that's, let's say, Hardeep map join output 1. Okay, done. See, reducer did not go to 100%. Reducer did not progress. The reason is reducer is not running because it's a map side join. If I look at my output, MJ01 Hadoop fs-ls. Okay, it's part M. I'll just cat this file. Okay, I forgot space in between. Right, I did not give any space, but you can get the output, right? This is the population from year to year, state year, right? So here my join is obtained. So guys, what I'm thinking is, so whatever are there in the Edureka's website, so some of the codes do work, right? Some of the codes are pretty old. I mean, the methods are deprecated. So what I'll do is I have the latest one. I mean, I have done this coding myself. So I'll be sharing all the codes at the end of the sessions, right? I'll be creating a zip file and I'll be sending it across to everyone. Okay. And the last part for this module is sequence file. So we'll quickly take this up and take a break, and then we will start with pick. Okay. Now sequence file, it's very simple. It's just a type of file which Hadoop can take advantage of. Okay. Now I know we have less of time. Just I will ask you some questions. Okay. Tell me. Let's see who can answer this. Okay. Let's say I have 10 files. I have 10 files. Every file is of size 10 MB. Right? So the total size I have is 100 MB. Right? Total size I have is 100 MB, but that's distributed across 10 files. Right? On these 10 files, I write a MapReduce job. Okay? On this entire 10 files, I write a MapReduce job. Can anyone tell me how many mappers would be created? How many number of mappers would be created? Any thoughts? Okay, so Shiva says 10. Okay, Sanip wants to reiterate the question. So the question is, Sanip, I have 10 files and every file size is 10 MB. Okay, I have 10 files, 10 MB each. If I run a MapReduce job on these 10 files, how many mappers would be created? Okay, Minesh says 10, Kodandarao says 1, Shiv also says 10. So the right answer is 10. Okay, the right answer is 10. Always remember, okay, I'll give a statement, right? Your input split, okay? Your input split can be all or part of a single file. I'll repeat this statement again. Your input split can be all or part of a single file, right? This means let's say I have a file of 200 MB. All right. If I split this as blocks, I would be having two blocks, two splits, if you say. All right. First would be of 128 MB, and second would be of 200 minus 128. All right. But if I have, let's say, 5 files of 5 MB each, okay, in this case, my total size, if you see, it's 5 MB each and 5 files. Total size is 25 MB, which is less than my block size, right? My block size is 128 MB. But still in this case, your input split or your blocks, it cannot spawn two files. Okay, it cannot club multiple files together. So this entire file would be one block, one block, one block, one block, one block. So there are 5 blocks. 5 blocks, that's equal to 5 mappers. Okay. So your input split or your blocks, this same thing happens in case of your HDFS also. If you try to keep lots of small files, if you keep 10 files, 1 MB each, 10 blocks would be created. All right. So always remember this. Your input split or your block size, right? It cannot spawn multiple files. It can spawn multiple blocks of the same file, but it cannot spawn multiple files. Getting it? Okay. So if my file, so this is a small file problem in your Hadoop, right? If you have lots of small files, okay, if you have lots of small files in your Hadoop, it will end up creating multiple mappers, lots of mappers. Okay, let's say I have 10,000 files, which are very small. Okay, if I have 10,000 files, it will consider that as 10,000 blocks. Though the sum of the size of these 10,000 files is, let's say, 500 MB. Okay, ideally 500 MB, it would be hardly 3 or 4 blocks. Okay, but it would create 10,000 blocks. Imagine 10,000 blocks for processing it, 10,000 mappers. 10,000 mappers, each mapper running inside a container. Imagine how much time it will take to process your file. Right? So there are lots of issues with small file in Hadoop. So you should never keep small files in Hadoop. Okay, now let's say you have a use case that you cannot avoid small files. Okay, you cannot avoid small files. Now what you will do with these? Okay, so either one thing is you can merge all the small files together, as Minesh says, right? You can merge all the small files together. But let's say I have 5 million small files. Now how will you merge 5 million small files? It will be very heavy on the CPU, right? You cannot merge everything on a single machine. I cannot keep 5 million files on a single machine and merge it. The machine will crash. Okay, so for this, okay, your Hadoop has something called as sequence file, right? Your Hadoop has something called as sequence file. There are other cases also. What you can do is you can compress all the files together, all the 10,000 files or 1 million file. You can create a zip file, right? Zip file would be a single file, right? That is also possible. Okay. Now, what is this sequence file basically? It's a binary format file. Okay, it's a binary format file. It manages your data inside this file as a key value pair. Now don't get confused again. This is not your MapReduce key value. Okay, it's just like a Java or Python key value pair. Okay. So it maintains your data inside keys and values. So a typical use case why the sequence file is used. So let's say I have lots of small files in my data. In a particular folder, I have lots of small files. Let's say I have 1,000 small files. Okay, I can club these together into one big sequence file. Now, how will I identify that out of this 1,000 files, if I've clubbed this together, from which point to which point is my file 1, from which point to which point is my file 2? It becomes very difficult. That's why sequence file, what it does is, it contains a key value format. So what you can do, while converting it to a sequence file, you can keep the key as the file name. You can keep the key as the file name. You can keep the value as your file contents. So Manish has a question, can I create parameter file which has all the names and read in mapper? Yes, yes, Manish, you can. Yeah, it is out of way, but yes, you can. Okay, so this is a sequence file. So you can club multiple files together, and to identify from what point to what point is your first file or second file or third file, you can keep the key as the file name and the value as the file contents. This is usually what we usually follow. So for example, so if this is your file, so let's say this is my file 1, my file 2 has these many lines, my file 3 has these many lines. So these are 3 different files. I can create a one big file. I can keep the key this small file f1, I can keep the contents as a value. I can keep the key as this file F2. I can keep the contents as this value. I can keep the key F3 as a key, and I can keep these contents as a value inside a single big file. This is a sequence file, right? This is a sequence file. Now the best part with sequence file is sequence file are splittable. Okay, sequence file are splittable. When I mean splittable, so you can splittable in terms of, I'm talking in terms of map reduce job. Okay, so sequence file you can give as input to map reduce job without any extra configuration. Your mapper will read it. Your Hadoop will read this file without any extra configuration, right? Because your Hadoop knows what is a sequence file. Hey, am I audible now? Great. I think there was a network glitch. All right. So I was talking about sequence file. Where's the paint? Yeah. So the best part with sequence file is it is splittable, right? So if you have a 10 GB sequence file, it would be splitted and multiple mappers would be running on my sequence file. So I'll be having 80 mappers. All right. Great. So let's look at the types of sequence file. I would just start that book. Okay, so there are three types of sequence file: uncompressed key value records, record compressed, and block compressed. So the one which I had shown you on the pane, that was the first type. Okay, where you don't compress the key and value. All right. The second type is you can either compress the value or you can compress both key and value. So it's just a type. Okay, there is nothing very significant about it. Okay, if you look at schematically, right? So if you see the first thing, I'll just, yeah, this first thing is your sequence file, right? When I say record compressed, that means each record, right, the value would be compressed. Okay, this is called as record compression. The other type is block compression. That means your everything would be compressed. So if you look at block compression, okay, so everything would be compressed: keys, values, lengths, everything. So these are all your headers. Okay, so nothing much significant about it. Just keep in mind, it's a binary format. It is used for clubbing multiple small files together in a single file, right? It is splittable and it can be directly fed to your Hadoop, that's to your MapReduce job. Okay, now one very interesting thing we will see about sequence file. Okay, one very interesting. What we'll be doing is, so we'll be doing image processing. Okay, we will be doing image processing, kind of image processing. Let's say I have multiple files. A typical use case I'm discussing, I have a demo on this also. Okay, so let's say I have multiple files. Okay, and those are image files. The file names are different, but the image is actually duplicated. So a same image is coming multiple times with different file names. Okay, this is my problem. That I have thousands of files, and out of that 1,000 file, 500 files are getting duplicated. It is getting repeated. Now, based on file names, I cannot remove the duplicates because the file names is unique for every file. What I need to do is I need to check the file contents. I need to check the image inside that file, and then I need to delete the duplicate. Now I have thousands of files. It becomes very difficult for me to open each and every file, check if it's repeated or not, and delete. It's very difficult. Correct? So what I can do is I can use Hadoop for this. I can use MapReduce for this. So what I will be doing is I will be clubbing all of these files into a single big sequence file. Right? I'll be clubbing all of these files into a single big sequence file. Now, how will I do that? So let's look at the code. Okay, everyone is clear with the problem statement? Great. Okay, so what I've done is I've written a mapper. Okay, in a normal MapReduce job, I've written just a mapper. I don't require a reducer to convert to sequence file. Okay, so what I'm doing is I've written a mapper which extends mapper. Input is a normal text input format. So the key value would be text, long writable and text. But the output key I am keeping as text, and output value I'm keeping as bytes because I am using sequence file. Sequence file can take only bytes. It's a binary format. Okay, so output I'm saying bytes writable. So bytes writable is also a writable which is available by default in your Hadoop. Very similar to your long writable text or your int writable, short writable, that way. Okay, what I'm doing is I would be reading the file one by one, line by line. Now this file is an image file. Sorry, this file is an image file. So what I'm doing is I'm reading the entire file. Okay, I'm reading the entire file and I'm storing it inside a string builder. So what the string builder will contain? The entire string representation of that image, right? And ultimately I'm sending the image path. So, okay. All right. So this input, okay, this is not an image. Okay, I'm not running it on an image. I'm running it on a file which contains path to the image. So I'll give you an example. Let's say this file. It's there in my Linux. Okay, I'll just close this Eclipse. It's making my Ubuntu slow. All right, this is the input to my that particular sequence generator job, MapReduce job. What it contains is, it contains path to the files. These are all image files. Right? What I will be doing is, I would be reading this path. This is an HDFS path. I would be going to this path, reading the file, which would be the actual image, and converting it to a byte format. Right? So if you look at the code, that's what I have done. This value would be the actual path of the file. I am opening that path. Right? I am opening that path, and I'm reading that whatever is there in that path. So ideally, those would be the images inside a string builder. And ultimately, I'm writing the path of the file, which is this path, as the key, and as the value, I'm sending the string representation, or sorry, the byte representation of my image. Right? Any doubts in the mapper? So this value is the actual file path, and this the key value where I'm outputting from my mapper, this value is the string representation or bytes representation of my image. All right, any doubts in the mapper? Great. That's it. I'm not writing a reducer. This will solve my purpose. Right? I just want to output the byte representation of my images. So that solves my purpose. I'll be writing a driver for this. Right? So I've written a driver. Okay. Simple normal driver. Setting mapper class, output key class, output value class. Things to note here is output format class is sequence file output format. So this is an inbuilt output format of Hadoop. By default, it is text output format, right? But now I'm setting it to sequence file output format. Okay, that's only a twist in your small twist in your driver. Okay, so after running this, I would be having a sequence file, a single sequence file, which would have all these files, all these images basically clubbed together. All right. Now what I would be doing on those image files is I want to remove the duplicates. Now for removing duplicates, what algorithm I would be following is I would be reading the file. Okay, I would be reading the image file that's from my sequence file. I would be calculating the MD5 hash of that file. Everyone knows what's a hash, correct? So the same hash thing which we were discussing in your MapReduce. Okay, I would be calculating hash of that file. Okay, if the contents are same, the hash code would be same. Correct? If the contents of the file are same, that means the image is duplicate. That means the hash code would be same. So what I'm doing is I'm writing a MapReduce job. In my mapper, okay, in my mapper, I'm simply outputting what I'm outputting, whatever value I'm getting as a byte writable here, that would be the actual image of my sequence file. I'm calculating MD5 hash, and that MD5 hash I'm outputting as the key, and as the value, I'm outputting the file name, right? As the value, I'm outputting the file name. So if you look at this calculate MD5 method, what it is doing, so it's a pretty standard method. If you just Google for how code to calculate MD5 hash, this is a pretty standard code. It will calculate MD5 hash for any byte array. So I've given that byte array, which is basically my image, to this method. It calculates the MD5 hash, all right, and it sends it to my reducer. Okay, when it comes to my reducer, sorry. Okay, now let's say I have two files with the same MD5 hash. This means that two files are duplicate. I want to only pick one of these because I want to remove duplicates, right? I want to only pick one of these, and I want to basically ignore the second. So what I'm doing is, in my reducer, what I will have the file name, and as a list, I will have MD5 hashes. And so on. Okay, this is what I'm getting in my reducer, because that is what I'm sending it from my mapper output. Okay, the MD5 hash, I'm setting it as my key. So I'll be having a list of all the MD5 hashes in my reducer. Now, if this MD5 hashes is coming same, that means the file is repeated. I'll only pick up the first one, right? So if you're looking at this, I'm just picking the one. So I'm applying a loop on this particular iterable. I'm just picking the first thing and I'm breaking the loop. So if there are multiple, I'm ignoring it. I'm just picking the first thing and I'm breaking the loop. That becomes my file path and the key. Getting the logic of how will I be processing it after converting it to a sequence file? Okay. So you're clear with the logic, right? Anyone has any question? Okay. Okay, so the thing to notice, this key here, which I'm getting here, okay, this will solve your answer, Rahul. Okay, so this key here is the file path. This value here is the contents of the file. Okay, that's basically the string representation. Right? When I'm outputting it, right, this value I'm making as a key, which would be the MD5 hash. Okay, so your value I'll be having MD5 hash, and the key would be the file path. This key, correct? I'm sending it out as a value. Right? So this would be the file path as a value, and this would be the hash value. When it comes to my reducer, okay, this key is basically the hash value, and this is the file paths. Okay, so if one or more files have same hash value, it will come to the same reducer. So initially, I just mistaken it. So I would be having the hash value as the key, and I'll be having file names as my values. Okay, sorry for the mistake. It's a bit confusion. So hash value I would be having as a key and file names as my values. I would be just picking the first file and ignoring the remaining files. Right? Let's run it. Let's run it quickly. So first thing what I'll be doing is I'll be converting it to a sequence file. So if you look, I have all the images. I have all the images here. Right? Basically, all the images are same. Just a bit of contrast or brightness has been changed. Okay, but the file names, see, the file names are all different. Auto loan, blur one, credit card loan, flower, right? That way. I've placed these images already to HDFS. Now, okay, it's opening. Now see, there's not a much of a difference. My first image, oops, first image. See, if you see, there's a small difference. Right? See, if you see this flower and this credit card loan, these are same. Okay, so ideally this should be removed. Okay, but we cannot open each and every file and check this. That's why we require this particular algorithm. So what I'm doing is I'm running a MapReduce job. So I already have these images placed on my HDFS. Okay, I already have these images. The input file for the sequence format, which is this particular file, the path of my images, which would be input to my sequence file MapReduce job. This is also there in my Hadoop. Sequence input.txt. Okay, just to be sure, I will add this file. Great. Now I'll run my sequence file. So my jar, okay, image. This is the jar, image.jar. So I'll be running a MapReduce job, Hadoop jar, path of my jar, then the main class. The main class. So if you notice, in the same jar, I have two drivers. One for my sequence file, one for my MapReduce job for processing, for removing duplicates. So I'll be running with the first driver, convert to sequence driver. My input path would be user. I had copied the input path. My output path, I can give it anything. Let's say user, hd user 123. Right, so there is no reducer here, it's only mapper. It will finish fast. Though it is only running a mapper, but I haven't made a number of reducers to 0. That's why it is just showing reducer, but it is processing nothing. But still my file name would be part R because I haven't made my reducer 0. Okay. So by default, single reducer is running. So if I look at the output, I would be having a part R file. Okay, let me just download this file. onto my desktop. Okay, now it's a sequence file, right? Now this part R000, it's a sequence file. I have successfully converted my 10, 12 images into a single part file. That's a sequence file. Now the sequence file is a binary format. I cannot open this file and read this file. It is binary, it's bytes. Okay, just to give you a demo how it looks like, let me just cat this file. See how it looks like. It's all binary. My notepad, my Linux cannot read this, right? It's all binary format. So this is basically your image converted to bytes, right? So if you try to open it inside a notepad or text pad, you won't be able to read this file, right? But Hadoop would be able to read it, all right? So I've successfully converted it into a sequence file. Now I'll be running my MapReduce for getting the duplicates. So the same jar, just my driver will change. My input will also change. My driver is now image driver. My input is the part file. That's the sequence file which was created. Okay, let's give any output. So this 234 folder will have my final output, which will basically have the file names with duplicates removed. So until this is running, let's count how many files I had earlier. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I had 11 files. After removing duplicates, let's see how many I have it now. Right, so it's done. Hadoop fs-cat 234 was the folder name. Part, I just do ls first. So this is the file. I'll just cat this 234 part r00000. Initially it was 11. After removing duplicates, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 files were removed. 2 files are duplicates. Right? So the key which I had kept was the file name, and the value I had kept was the MD5 hash. So this is the hash value. This is the MD5 hash. And it has removed duplicate files. Right? Getting this? Any doubts? So guys, here we are. We have finished with MapReduce. Right? So now, so basically we are done with the core. We are done with HDFS. We are done with MapReduce. That forms the core heart of MapReduce. Is my voice breaking? Okay. So the next thing is the frameworks which are built across MapReduce. Right? So we'll be starting with Pig as the first framework. Let's take a 10-minute break. Okay, and then we will start with Pig. So it's not a logical break, it's an actual break. So let's take a 10-minute break. It's 10:30. Let's start at 10:40 with Pig, with fresh minds. Right? So this was the last slide. So I'll just set up a timer of 10 minutes. Okay, if anyone has any question, they can post it. We can take it after 10 minutes. Hey, so I hope everyone is back. Okay, so let's get started with pig. Okay, now to give you background of pig. So basically, pig is a framework which works with your Hadoop. Now, when I say Hadoop, that includes both your HDFS and MapReduce. Okay, now this tool was developed by Yahoo. Now, what was the need of this tool? Okay, now up till now we have seen MapReduces for which we were using Java. You can use Python, C Sharp, any language, but you were actually coding it. Okay, now with pig, what is the advantage you get is pig is used to process your data, to analyze your data, but it does not require any programming skills. Right? You can write a MapReduce without Java using pig. Okay. Now pig is very supportive. It's very similar to SQL. Right? It's supportive of a programmer writing a query. All right. It's very similar to SQL. It's high-level English-like statements. Okay. It's a very high-level language. Okay. It's a scripting language, you can say. Right. So pig has its own language called as pig Latin. Okay. It has its language called as pig Latin. Right. Now this pig Latin is a scripting language which is used to which is very similar to SQL, high-level English-like statements. It converts your script, okay, to a MapReduce job by itself. Okay. See, ultimately, your data would be fetched using MapReduce, right? But you're right. You're not creating any jar. You're not writing any Java code. Okay. No mapper, no reducer, no driver, no creating a jar, nothing. Okay, you will be simply writing half a dozen of line for in your pig Latin, which will do everything for you. So it's basically a language layer. It's a language layer which converts your pig Latin to MapReduce. Right? Now the best part is, so let's say I want to do word count. Now for doing word count, what I did, I wrote a mapper, which was let's say around 10 lines. I wrote a reducer, which was say around 5 lines. Okay, 15 lines. Then I wrote a driver, which was say another 10 lines. Okay, so around 30 lines of code I'm writing. I'm converting it to a jar. I'm doing so much of messy things to run it. Okay, now if you're doing it with pig, pig's word count is hardly 4 lines. That's it. Just issue 4 lines, entire word count is obtained. No need of creating jars, no need of writing mapper, reducer, driver, nothing. Right? So development time has reduced a lot. Your number of lines has reduced a lot. So basically development effort has gone down. All right? That was why that is why pig was used, pig was developed. Okay? So if you don't know Java, still you can use pig. 10 lines of pig is equal to 200 lines of Java. Okay, so it's a very high level language. It has built-in operators like join. You can do join in pig, group, filter, sorting, everything. Like whatever you can do in your SQL, same things you can do in pig. Okay, why pig should be used? So if you see lines of code, in normal MapReduce, you'll be writing so many lines, and in pig, it is hardly this much, right? So if you're coding less, your development time has reduced. Okay, if you look at development time from this much, it has gone here. Right, your development time has been reduced. But remember, guys, in terms of performance, Pig would be slower than MapReduce. When I say MapReduce, that's the Java MapReduce. Pig would be slower because Pig is a language layer. There is an additional step of converting your Pig Latin to Java MapReduce. So Pig would be slow, right? Pig won't perform as fast as your Java MapReduce, but still it is reducing your development time. In the previous versions of Pig, this performance gap was very huge. But as the latest versions of pigs is coming, they are developing sophisticated algorithms, okay, which is reducing this, which is narrowing this gap of your performance. Okay, so unless you are willing to spend time in optimizing your Java MapReduce code, writing your scripts in Pig will save your time. All right. Now we know what is MapReduce. It's used for powerful model for parallelism based on a rigid procedural structure, provides a good opportunity to parallelize algorithm. And what Pig helps it in? It is desirable to have a higher level declarative language, similar to SQL, where the user specifies what and leaves how to the underlying processing engine. Right? So you just specify what to do. How to do it, your Pig will take care of it. That's ideally using your MapReduce. Okay, so why Pig? So first important thing, Java is not required. That's very good thing. Okay, Java is not required. The best thing is it can also work with different types of file. So your Pig can be used for unstructured files, semi-structured, basically all the variety of files. Can take any data. It can work with structured, semi-structured, unstructured. It is easy to learn, easy to write, and easy to read. Similar to SQL and reads like a series of steps. So Manish has a question. Do you know why they are using all animal logos? Pig, elephant. So it's all like a zoo. They also have a zookeeper. There's one more framework called as Apache Zookeeper. Right. By the way, Hadoop name came from Duff Cutting's child's toy. Okay, he had a toy elephant to which he named as Hadoop. So it's inspired by, the name is given by a child. Okay, so it reads like a series of steps. It is extensible. So whatever functionality Pig is giving you, the best part is Pig is written in Java and Pig is open source. Okay, Pig is also written in Java. And you can basically, so like in Pig, you load data, you store, you filter, you group, you join, you do a lot of things. So everything can be extended, everything can be customized, writing UDFs. Now UDF stands for user defined functions. So you can write a UDF in Java, Python, JavaScript, Ruby, right? It provides common data operations like filter, join, ordering, and nested data types, right? Data types would be discussing in the coming slides. It has something called as tuples, bag, and map, which are not there in MapReduce. Right? We will discuss about the data types in the coming slides. It has an ad hoc way of creating and executing MapReduce jobs on very large data sets. See, for writing Pig, you just require an environment where you can write Pig Latin, right? You're not converting it to jar, right? So it's very simple. You can just write ad hoc 2-3 lines of Pig script and it will do everything for you. Okay, so see, frameworks are actually meant to reduce your workload. Okay, it's frameworks are meant to make your life simpler. Okay, why Pig was developed? Because Hadoop, not everyone can actually go and code. Right? That's why such tools are developed. Same with the case of Hive. Why Hive is developed? Because no one can, and not everyone can go and write a Java MapReduce. Right? That's why these frameworks are evolving. These frameworks are developing. It is just to make your life simple. Okay. It is open source and it is actively supported by a community of developers. Okay, where should pig be used? It is on top of Hadoop and makes it possible to create complex jobs to process large volumes of data quickly and efficiently. Right? You can use it for time-sensitive data loads, processing many data sources to get insights through sampling. So these are some use cases where you can use pig. Okay. See, once we look at how pig works internally, how to write a pig Latin, how a pig code looks like, it will become more interesting. Now, where not to use pig? So where you have really nasty data or completely unstructured data, okay, like your videos, audios, your human readable PDFs, text, those kind of data, you should avoid using pig. Okay, you should not use it the where the business logic is very complex. So Minesh has a question. It can process JPEG and PNG files also. Yes, it can, because ultimately it's a MapReduce job. So you can use pig to process it, but the coding is very nasty. Okay, because in pig everything, so pig only work with data structures. So everything you're doing in pig should be maintained inside a data structure. So you can do it, but it is said that you should not use pig for processing images. Okay, so Shiv Prasad says, in these scenarios, what would be the alternative other than Java? So Java is one. Then other is you can use Spark. Okay, you have Scala. Right? Then you can use Python. All right. And then you have some image processing frameworks provided by Hadoop. One is HIPI, H-I-P-I. Right? That stands for Hadoop Image Processing Interface. So there are lots of other tools available for processing audios and videos, which works with Hadoop. Okay. And the third, where you should not use pig is when you would like to you like more power to optimize your code. So basically, if you want the control how your code should execute, you should not use pig, because pig will plan its own execution steps. All right, it's pig's responsibility to convert your script to MapReduce steps. But if you're writing it on your own, you have very very low level control on your code, how it is executing. Okay, so Apache Pig is a platform for analyzing small data less than 10 GB, large data, or all of them. Okay, so Bhaskar says large data, Rahul says all remaining all says all. Okay, so the right answer is large data. Okay, see, small data, you should not use Hadoop itself for small data. MapReduce also should not be used for small data, because there's an overhead of creating a huge mapper and processing very little of data. Okay, so small data, you should not use Hadoop. Okay, data less than 10 GB, 10 GB is still very small. Okay, but Hadoop is actually meant for large, huge volumes of data, where your normal database cannot process, where your power of your database comes down. That's the place where your Hadoop shows its power. Okay, so the right answer is large data. So Pig is an open source high level data flow system. It provides a simple language for queries and data manipulation, which is called as Pig Latin, that is compiled into a MapReduce job that are run on Hadoop. Why it is important? Companies like Yahoo, Google, Microsoft are collecting enormous data sets in the form of click streams, search logs, and web crawls. Some form of ad hoc processing and analysis of all of this information is required. So as mentioned, Pig is used for ad hoc analysis, where let's say I have a huge data set which came just now. I want to process something. It's very nasty for me to write a MapReduce job in Java for this. Okay, in Pig I can simply issue 2-3 lines of code and my job is done. The best part with Pig is, let's say for processing some data, you already have a small Python script available, or a shell script available, or a Ruby script available. The best part with Pig is it can interact with your existing scripts. So basically you can trigger your existing Python code through Pig. Okay, you can basically execute your existing shell script through Pig. That's the best part with Pig. Doing this in normal Java MapReduce, this is very difficult. Okay, so it's very supportive from your it's very supportive with your developer. Okay, and the best thing is this is interactive. So whatever command you send to Pig, immediately it will send the output to you. It is interactive, just like a shell. Okay, Pig has a shell. We will see this in the coming slides. Okay, so these places your Pig is used. Processing web logs, data processing for search platforms, ad hoc queries, which we have been discussing till now, quick prototyping. Okay, so if you just want to prototype a specific algorithm, doing it in Pig would be very fast. I'll tell you a case where we use Pig. So initially when we started with our project, so at that time we have huge files. Okay, and as a pre-processing step, we wanted to give row numbers to every row in the file. Right, so there were around 50 to 60 million of rows in our data. Right, what my use case was, I wanted each row to be identified uniquely. That was possible if I generate a row ID, okay, a unique row ID. For this particular step, I am using Pig. So Pig has an inbuilt function. It can rank over and generate row numbers. Right, so on a huge 60 million data set, right, so we run it on a 40 node cluster. On a huge 60 million data set, the size is around 1 TB, right? And it's a gzipped file. It takes around 30 to 35 minutes, right? Which is a very good time for 50, 60 million. 30 minutes is a very, it's not a very huge time, right? Imagine 1 TB of data, it is going to every row generating an ID, right? So ultimately, that's not a power of Pig to be specific. That's a power of MapReduce. So Bhaskar has a question, you update the file with the row number or row number generation while processing. While processing Bhaskar, I don't update you cannot update the file in Hadoop, right? So while processing it, I generate a row number and I put it inside a table. Right? I cannot update the file there itself because it's there in Hadoop. Yes, inside. So what I'm doing is I'm reading a file from my Hadoop and I'm putting it at a location on which there is a Hive table. So we haven't discussed about Hive till yet. Just to tell you, so I am putting it at a location where there is Hive. So I'm adding a row inside my Hive table where my Hive is referencing it. Okay. And nowadays, Pig mostly it is used for all your data quality checks. Okay, the most places where Pig is used is, so let's say you want to do some quality check on your data. For example, there is a total row count check or numeric check, or let's say you have some fields. For example, in your data you have a field like email ID. You want to check is, or let's forget about email ID. Let's say you have a PIN code. You need to do some data quality check that the PIN code should be numeric and the number should not be more than 5. So such types of checks we usually implement in Pig. Right? Instead of writing a MapReduce job for this, this step is well handled writing a Pig program. Okay, this is an example. So example of data analysis. So let's say I have two files. Okay, I have pages and each page has a rank. So these are basically websites, and every website has a rank, that is this website a good website or a bad website or an average website. I have lots of users which are basically visiting these pages. So on every click, basically it is generating data. So this particular data, if you see, it's actually Okay, so it's basically coming from your browsing history, like which pages you're visiting and for how much time you're visiting it, based on your user ID and all. Okay, so let's say I want to have a particular algorithm which checks that which users tends to visit good pages. Now, when I say good pages, so the algorithm, the logic can be anything, but according to me, the logic is the average page rank for that particular page should be more than 0.5. Okay, it can be any logic. It's just a logic, right? So let's say the average page rank for that particular page should be more than 0.5. That says that particular page is good for me. So I need to basically check that out of these users, for example, Amy is visiting CNN.com. So CNN.com has a page rank of 0.9. So I need to check if it's a good visit or a bad visit, if Amy is visiting good pages or bad. Now on the screen you can see very less data, but in actual scenarios, imagine how many users and how many pages are there on the web. There are millions of pages, right? And how many users log in every day. So the data would be very huge. Okay, working with such a huge set of data and doing some algorithms, some checks like this, it's only some massively processing, parallel processing framework that can do it. Okay, and Hadoop is the best candidate. Right? So what we usually do in Pig is, whenever you start with Pig code, how does a Pig code looks like? Okay, so every Pig program has a left-hand side and a right-hand side. Right? Every Pig code has a left-hand side and a right-hand side, and it is series of steps. It is series of steps, right? And every left-hand side, okay, and usually your Pig starts from the load statement. So basically you would be writing a Pig program on a particular file. Now in Pig, so like if you consider, so we haven't discussed about Hive yet, but for those who knows Hive or database kind of things, in Pix there is no concept of a table. You're not creating table. Okay, you're directly working with files and the files which are there on your HDFS. So usually the first step of Pig is load data, and you give a path in single quotes, and the output, every statement has an output, and you store that output inside a variable. That is what I meant by every statement has a left hand side. All right, and it's a data flow programming language. It's a data flow programming language. So when I say the first statement's output is A, you will use this A in the second statement and you will have a different output, let's say B. Okay, you will use this B in the third statement and you will get C. Sorry. Okay, so basically what you're doing here is you're transforming this. So from the first statement you get an output A, you transform A to get B. Now this transformation can be anything. It can be a join, it can be a filter, it can be grouping, it can be anything. Okay, so you transform the first output and obtain a second output. All right, you basically transform the second output, obtain a third output. Let's say this third output is your final output. You can print this. Okay, you can basically print this output. This is a final output. So this is basically a series of step. Okay, your Pig is a series of step. All right. So this is how your Pig ideally will look like. For this particular algorithm, this is a pseudocode. So first what we will do is we will load the visit page, we will load the we will load the visits table and we load the pages table. All right, we will join these two on the basis of URL. All right, then I will group by user and I'll compute average page rank and I'll check whose average page rank is more than 0.5. That particular user tends to visit good pages. Right, so I'm joining the two tables based on the URL. I'm joining these two tables based on the URL and I'm grouping by users. All right, so how it will look like, Amy will be visiting CNN, crab.com, myblog, Flickr, okay, and every page would be grouped with your page rank, right? So from the page rank, I'll calculate average page rank and I'll filter those pages which has average page rank more than 0.5. So this is just a logic, okay, just a pseudocode. This is how you will convert your pseudocode to a pick statement, okay? So for now, just understand how the syntax looks like, all right? How many operators are there in pig? What are the data types in pig, right? We will have one overall demo of pig, which is, I doubt which it would be today. I don't think it would be today, right? So we will first try to cover the concepts of pig, right? How it looks like, how do you write a code in pig, where do you write a code in pig, how it is executed, how are the data types, right? We will see those concepts. And overall, maybe in the next session, the first thing we will do is we will have an overall demo of pig. Okay, everything would be covered there. So pig is best suited for data factory. Now, Yahoo is a developer of pig, right? Yahoo invented pig. Now, how Yahoo uses pig is, so it is basically used in the data factory. Now, data factory in Yahoo, it contains of two things. First is a pipeline where you're getting data. That's your source of data. So pipeline brings logs from web servers. So imagine how many users are logging to Yahoo every day. So Yahoo have lots of things like Yahoo News and lots of other things. So whenever you login, every click generates data, right? That data comes to your Yahoo servers using your pipelines. Okay, that's basically a name data. It's basically a channel from which your data is coming from your source to your Yahoo servers. Now, these logs undergo a cleaning step where all your company internal views, right? See, Yahoo pages can be visited by people who are working in Yahoo itself, right? So those internal views, these are filtered out, okay? Clicks are filtered out, your bots information is filtered out, okay? So there's a cleaning step, there is a data massaging step happening when it comes to your Yahoo web servers. All right. Now, when this data is cleaned, on these data, there are lots of researchers who want to quickly write a script and to test a few algorithms, okay, to prototype their algorithms. For these, they are using pig, okay, because if they do it in Java, for such huge data sets, it's very difficult for them because the data which they get has lots of fields, has lots of columns. To parse it properly, it becomes very difficult and very annoying to do it in Java or any programming language. With pig, it's very simple. Provide a delimiter, pig, everything has ready in terms of columns. Right? So it's easy to write, it's easy to read, it's easy to maintain. All right? And it's quite interactive. So pig interacts with streaming data and makes it easy for researchers to take to write a Perl or Python script and run it against a huge data set. So so these scientists, all right, already have some of their scripts running. Okay, so before pig, they already had their algorithms written in Python. Now they cannot scrap everything and accept a new language altogether. So what they did is they implemented a functionality in pig itself that it can interact with existing Python scripts, right? So pig has a syntax, it's called as stream. Okay, so it can basically interact with any of your existing scripts, and the scripts could be anything: JavaScript, your shell script, Python, Ruby, anything. All right. Now your pig basically has three things. Okay. Now this was all the background of pig, where it is used, where not to use, how it is used. Okay. Now coming to the actual technology, how to use pig. Right. What all it consists in terms of technology. So you can run a pig using a script. Okay, now what is a script? It's a normal text file which contain your pig commands. All right. Now, where do you run script? So there are two ways of running script. The first way is interactive. Right? When I say interactive, so there is a pig shell available. Now this pig shell is called as grunt. Okay, so if just to give you an example, if I just log into Edureka's VM, I hope they have pig installed. Yes. So if I just say pig and enter, it enters into grunt. This is an interactive shell of your pig. So this is the so let's say you write a statement, you can get the output here itself. Right? So it's interactive, just like a normal MySQL shell. All right. The other way is you can write. Okay, so first way is through grunt, that's your interactive mode. Second way is embedded. Basically, you can write your pig scripts using your Java language. So you can run pig programs from Java, much like you write a JDBC program. It's similar to a JDBC. It's not JDBC, but it's very similar. So pig has lots of pig. So Java has lots of APIs for pig to interact and submit your queries and fetch the results. Right? Yeah, so Minesh has a question just for info. Was pig available in Hadoop 1? Yes, Minesh, it was. Okay, just an info from my side also. The Ubuntu VM which I am using, this is Hadoop 1. Right, the VM which I have is, this is my personal VM. So this is Hadoop 1 and I have pig installed here which works fine. So all the code which we were running were actually running on Hadoop 1. And if you notice, when I was writing the code, I was writing it for Hadoop 2. That's the best part with Hadoop. Okay, doesn't matter it's Hadoop 1 or Hadoop 2. The code is same. The execution environment doesn't matter. The code and the output will be same. So for developers, that's why I mentioned earlier. For developers, Hadoop 1 and Hadoop 2 doesn't matter. Nothing has changed. Right? So if I do a JPS here, if you see, I don't have resource manager and node manager. I have job tracker and task tracker. This is my Hadoop 1. Okay. All right. Now, how do you write a code? How it is it case sensitive? For if you consider SQL, SQL is not case sensitive. There are few things in SQL which is case sensitive. Like if you're defining a string, whatever comes inside a single quote in a SQL, that is case sensitive. But in case of pig, it's a mix, right? It's a mix of case sensitivity and insensitivity. Now, what is case sensitive? So as I mentioned, like when you'll be writing a pig code, you will be every time having a left hand side, something equal to a step. Now this alias, like this left hand side is case sensitive. So this A and this A, these are different, right? So this alias is case sensitive. Okay. The pig functions. Now pig have lots of inbuilt functions like count, right? Min, max, group, all of these functions are also case sensitive. All right, and the case is all capital. Everything is capital. All right, the name of the parameters and all the other pig reserved words are insensitive. For example, if you want to load data, so if you write capital load or small load, doesn't matter. If I write it in this way, or this way, doesn't matter. All right, so the keywords are case insensitive. Right. So in the example, so this is how a pig script looks like. Right, this is how a pig script looks like. So what it is doing, I'll just so like don't worry about what is this pig storage and what is this everything. We will come to this. Okay. Now if you look at the script, the names of each relation, each left hand side, A, B, and C, these are case sensitive. All right. These name, age, these are all case sensitive. right? The functions, for example, this pick, storage, count, these are case sensitive, all right? But if you look at other things like load, group, name, for each, generate, these are all insensitive. You can use any case. Okay, it's a normal programming language. I don't think, I mean, so I think the class is intelligent enough. These are very small things to consider if we can just overlook these. Okay. Now there are two modes in which you can run pig. So very important thing. For pig, okay, so pig is basically a programming language kind of a thing, right? And the language is pig Latin. For using pig Latin, okay, for defining the flow of data, it is not necessary that you require Hadoop. Pig can work without Hadoop also. It is designed in such a way it can work without Hadoop. So even if you don't install Hadoop, it's fine. Pig can still work. All right. So how will you? But one thing is, it can only work with Linux. Right. Pig cannot work on Windows. Right. Though Hadoop is not mandatory for Pig, still it will work on Linux. Now, if you want to run Pig without Hadoop, then you have to start Pig with pig -x local. All right. And if you just type pig and enter, it will start in your Hadoop mode. That's your MapReduce mode. So the way I have started pig, I just said pig and enter. I've just said pig and enter. So I'm starting on your Hadoop. I'm starting it on MapReduce mode. Yes, so Bhaskar says pig internally converts into a MapReduce program. How it works without Hadoop. So Bhaskar, so your Hadoop itself, your MapReduce code itself can work without Hadoop. Okay, so if you remember, Hadoop has three modes. One of the mode is standalone mode, right? Where it does not even require Hadoop to be installed. It just uses the API, right, and run everything locally inside a single JVM. Right. So Rahul says, any performance difference? Of course, Rahul, you cannot use local mode for very huge files. On a single machine, you cannot process terabytes of data, right? Even if you try to process a 10 MB or let's say 100 MB of data, your machine may crash. Okay, so you cannot process huge amounts, but you can test the functionality. Like, is the way in which I'm writing my code that's working fine or not? Okay, you can debug, you can write, you can develop. It's basically for development purpose. Okay. Now the best part is, now with this grunt, this grunt can be used for interacting with your Hadoop HDFS also, right? From grunt itself, you can access HDFS. All right. You can also run shell script from grunt. So it's basically a environment which can be put to multiple uses. Not only pig programs, but you can access HDFS. You can use those commands. You can do a ls on Hadoop. You can copy from local, copy to local, get, put, CP, MV, all these kind of things which you don't do on your HDFS can be done from grunt itself. Now for doing it from grunt, you don't have to, like, how do you do it from a normal Hadoop shell, Unix shell? You say Hadoop fs hyphen, correct? For doing it from grunt, you don't require to type Hadoop. So if I just enter to pig, right? For accessing HDFS, I don't need to type Hadoop fs hyphen. I will just say fs and work with the command. So if I say fs hyphen ls, automatically it will do a ls on your HDFS. Yes, like Python. Okay, this is very similar to your Python shell. Okay, I can write an sh and run my shell command also, right? That also works. Similarly, this is what this slide says. Right. So this we have discussed. Pig is made up of two pieces. Okay, so Rahul says minus ls will give local list. No, no, Rahul, it will just give HDFS. You cannot do it for local, I guess. Let me just try it. On local, you cannot do it. Oh, so it only works on HDFS. It does not works on local, right? Okay, so pig is made up of two components. The pig code, the programming language, which is called as pig Latin, in which you define the data flow, and the second is the execution environment. So we have already seen the execution environment, right? It can be local or it can be MapReduce. Okay, now the best part with pig. Now pig is basically not a, it's a API kind of a thing, right? It is not a process. It's a utility kind of a thing, you can say. Now let's say, okay, I'll give you an example. Right? Let's say I have one Hadoop cluster. Right? Let's say on this machine I install pig. Let's say I have one more Hadoop cluster. Right? If I want to run a pig program on this cluster, should I install pig again here? Is there a need to install pig again in the second cluster? Considering I have access to both the clusters. Okay, so Rahul says yes. Shiv says no need. Minesh says no. And Minesh says as long as you can access. Exactly. So basically, see, when you're installing Hadoop, you're starting Hadoop, right? You're starting the processes. You're starting name node, data node, node manager, your resource manager. But in terms of pig, pig is not a process. Pig is just a language conversion layer. You just feed pig Latin, it will output MapReduce. That's it. Okay. So for using pig, you don't need to install it every time on every cluster. In fact, pig can be installed on a machine which is not even a part of your cluster. So I can have a machine here which can just connect to your cluster, and I can have pig here. This is not a part of a cluster. There is nothing running on this machine. No name node, no data node, nothing. Okay, so pig can reside with your client itself. So pig is basically a client. Pig can reside with your client. After converting your pig Latin to MapReduce, it can submit it to a Hadoop cluster, right? Pig does not needs to be installed on a cluster, right? So if you have 10 Hadoop clusters, a single pig installation will suffice. A single pig can connect to any Hadoop cluster. Ideally, same thing works with Hive also, right? So we will just remember this. Same thing works with Hive. We will discuss when we come to Hive. Okay, so pig resides on user machine and job executes on cluster. So it basically converts it to a MapReduce job, and so basically it converts it to a jar and submits the jar to your Hadoop cluster. All right, so no need to install anything extra on Hadoop for supporting pig. There's nothing, you're not even touching your Hadoop cluster if you want to execute pig. Okay, a pig Latin program. It is made up of a series of operations or transformation that are applied to the input data to produce output. And this we have discussed, right? So the same thing I was telling you. You basically load data in the first step always, which will result into some output, and you transform this every time in the second statement and get more outputs. All right, so it's a series of steps. So it is made up of a series of operations on transformation that are applied to the input data to produce output. Now remember guys, every step, basically right hand side, this is called as a transformation. Every right hand side, this is called as a transformation. Every left hand side, for example this A, B, these are called as relation. Right? Always remember this. Okay. The left hand sides are called as relations. The right hand sides are called as transformations. So you can safely say that every transformation results into a relation. Okay, every transformation results into a relation. Now this left hand side, basically relations. Now pig is basically a data structure kind of a thing. All these left hand sides are basically data structures. And to be specific, I'll just mention it now. We have a detail in the coming slides. These are just like your Java list. Okay, the left hand sides, those are your relations. The data type for this is a Java list. So it's basically a data structure. Okay, so all the left hand sides in pig are a data structure. And which data structure? It's a Java list. Remember this. If you get this concept, pig is very simple. There is nothing in pig. All right. So there are some things if you know in pig is very simple. Okay. So Mine says in Java we write code to read as single line. Similar thing you do in pig. No, Minesh. You just load file. By default, pig will read it line by line. You just have to specify that your file is delimited. You have to specify the delimiter, that it's a comma delimited, tab delimited, space delimited. Ultimately, if you're not writing any code to read file. Once you say load, that's it. Pig will take care of reading it line by line. Yes, it would be a huge file. So Minesh says it would be a huge file, right? Yes, it would be a huge file, but ultimately everything is getting converted to a MapReduce job, correct? Which would be triggered with parallel mechanism, right? So doesn't matter it's a huge file or not. Ultimately, every process will actually process only 128 MB. Okay, so Kodanda Rao says, who are primary users of PIC? Is it data analyst or anybody else? Okay, I'm audible now. Yeah. Okay. Yeah, Kodanda Rao. So I was saying the primary use case was for data analyst because for those only Hadoop, this PIG was developed, but it is used by others also. Okay. And what pig does, it turns your pig Latin program into a series of MapReduce job. Now see the best part with pig is, so when you're writing pig scripts, your script could be very complex. You could have lots and lots of transformations. All right. Now let's say if you're working at a Java level, if you're working at MapReduce level, you cannot do multiple things together in a single MapReduce job, right? For example, if you took a case of the employee data, where you were calculating sum of salary per department, and I wanted male and female count also. You cannot club these two, correct? But if you're writing a logic in Pig, all right, to club these two things, you will get a feeling that you're doing it in a single program. Ultimately, you are writing it in a single program. But Pig, as it is triggering map reduce job for this, Pig cannot guarantee that everything can be done in a single map reduce. So Pig can trigger, or Pig will definitely trigger a series of map reduce job. It will trigger multiple map reduce job. Right? I have also seen a very complicated Pig program, which when executed triggers around 20 map reduces. Okay, so Pig is very intelligent. It can make out, it will find the most optimized way to run your code, and it will try to spawn more map reduces. Okay, so that your entire logic could be processed. Okay, so for writing for your developers, what advantage you're getting? You're writing a normal script, though it is complex, but to you, you're writing it in a single program. Ultimately, when it's executed, Pig will turn that into multiple map reduces and then trigger everything on your Hadoop cluster. Right? So that's what was the first statement in Pig, right? You just say what to do. How to do it, Pig will take care of. Okay. Now data types of Pig. So what we'll do is we will see the data types and we will stop for today. So we are already above time. So let me just check what is next. Okay, we'll just cover 2 slides and we'll stop for today. There's nothing much. So there are 4 important data models in Pig. Okay. First is called as an atom. Okay. It's also, this is basically a field of your data. Okay. It's a single field of your data that's called as atom. All right. Then there is a tuple, there is a bag, and there is a map. Okay. Now what is a tuple? What is a bag? What is an atom map? We have in the coming slides. Okay. Okay. Now see guys, this is very important. If you understand this, 90% you are done with Pig. Right? If you understand what are the data types of Pig, you know 90% Pig. Okay, it's that important. Right? Now the first complex data type of your Pig, the first data model of your Pig is called as a tuple. Right? Now what is a tuple? Tuple is just like your Java list. Okay, tuple is just like your Java list. Kudandara, I didn't get what you asked. Yeah, it is same like Python tuple. Right? Multiple fields together. It's similar to Python tuple. Okay, someone pronounces it as tuple, someone pronounces it as tuple. Okay, one and the same. Okay, now tuple is basically just like a Java list having multiple fields. This is a tuple. Now the fields can be anything. It can be an integer, it can be a string, it can be a double or float. Okay, it can be anything. Right? So this is a tuple. It's kind of a Java list, all right, having any type of fields. Right? This is a tuple. Always remember in Pig. I have a question. No, so Chaitanya says all should be of the same type. No. Okay, it's of mixed type. It can be any type. So it's a Java list and the fields can be of any type. So if you see the first field as an integer, second field is a string, third is a third is a float, fourth is an integer. So Bhaskar says basically it's a record type. Now you can consider this tuple as a row of a table in your database. Okay, you can consider a tuple as a row of your table in a database. Basically, each field will have a schema also, right? Each field in your tuple has schema, all right? So tuple is an ordered list, okay? It is ordered. It means you can access this through positions also. This is position 0, this is position 1, position 2, position 3. This is ordered because you can access using positional notations also. Okay, always remember anything in pig which is coming in parenthesis, round brackets, is always a tuple. Anything in parenthesis, right, round brackets, it's always a tuple. Okay, now the second data model of your pig is called as a bag. Now simple, what is a bag? Bag is a collection of tuples. Bag is a collection of tuples. Anything in pig which comes in curly braces, it's a bag. All right, and the tuples which are there inside this bag can be of any length. So for example, this is my first tuple. Second tuple. Third tuple. Getting it? Okay, so basically this bag contains 3 tuples. The first tuple contains 1 field, second tuple contains 2 fields, third tuple contains 4 fields. So this is possible. This is a bag. It's a collection of tuples and every tuple inside the bag can be of any length. Any doubt in a bag? What is a bag? So this tuple and bag are very important. These are very important. If you know this, I mean the pig is very simple. There is one more data model called as map, okay, which is not used much. It is, I mean, I would say it is hardly used. Okay, what is a map? Basically, it contains key value pairs. It's just like a Java map. Okay, anything in pig which comes in square brackets, it's a map. Okay, so this is the map. This is a map in pig. Key and value are separated by a pound character. Right? There is one limitation in map, the keys. This is the key. Key can only be string. Value can be anything. So if you notice, all the keys I have mentioned, it's a string. Right? This is how pig's implementation is. You cannot change this. Right? So getting what is a bag, map, tuple, right? And each field inside these are called as atom. So atom is nothing but a field. Right? So if you just go to the slide, a field is a piece of data. Tuple is an ordered set of fields. Parentheses are used to indicate tuple data type. Yeah, Abhilash has a question. Can the keys be more than 2 letters? Yes, it can be. It can be 100 letters also. I mean, there is no limitation on that. Okay, so Bhaskar says, can you repeat difference between tuple and a map? So Bhaskar, tuple, first difference is tuple is in parentheses. All right, map is in square brackets. All right, tuple can contain any number of fields of any data type. Okay, it's just like your non-generic Java list. Okay, so if you know Java, so in Java, if you define a list L equal to new list, new array list. So this list can take any data type, right? You can put an integer also, string also, float also, double also, unless you make it generic. Unless you make it generic, this can accept any data type. All right. So basically, tuple is a non-generic Java list. So I don't use generics in tuple. You can say it's a normal Java list without generics. That means it can accept anything, right? So I can have a integer value, a string value, right? A float value, any, I can have a bag also inside. I can have a bag inside a tuple. That's also possible. And I can have, let's say 5. Right? This is my tuple. Yeah, Rahul says order means insertion of data. Yes, Rahul, insertion of data and also how to access data. And Bhaskar says you said bag is a collection of tuples, right? Yes, Bhaskar, bag is a collection of tuples, but it can be a very complex data structure also. A tuple can also contain a bag. So if you see here, how many fields this tuple has? It has 5 fields. First field is an integer, second field is a string, third field is a float, fourth field is a bag, fifth field is an integer. This is possible. And this bag internally can contain multiple tuples. Getting it? It can be a nested data structure. Tuple can contain bags also. Right? But that would be treated as a single field, a single atom. So Minesh says like header row and transaction row, sort of. See Minesh, in Java also, like others who know Java, and for Minesh, you also, like in Java, if you define a list, you can put anything inside a list. You can have a list inside a list. You can have a map inside a list. Same in Python. All right, you can have a very complicated data structure. Similarly, this is a complex data structure. You can have a bag inside a tuple. All right. Okay. And the second difference you asked is map, right? So map is basically a key value pair in which you specify a key. Let's say a key is A, and the values for this key A is 1. Right? So this is the map. You specify key and values. Right? The only limitation is key has to be strings. I can have any key. So let's say this is my second key value pair. This is also possible. So A, B, C, X, Y, Z is my second key and my second value is 2. Okay, keys and values are separated by pound, hash. All right. So this is a difference between tuple and a map. So a tuple is an ordered set of fields. This are used to indicate the tuple data type. A bag is a collection of tuples and curly braces are used to indicate bag data type. A data map is a map from keys that are string literals to values that can be any data type. So this is what I meant. Your keys can be only string, values can be of any data type in case of a map. right? Straight brackets or also square brackets, right? These are called as map. So if you see this example, tell me what is this? Is it the tuple, bag, map, or everything? So Rahul says tuple, Chaitanya says tuple, Bhaskar says tuple, Minesh says everything. Okay, so it's a tuple, Minesh. And tuple contains how many fields? How many atoms are there inside these tuples? How many fields are there inside the tuples? Exactly. Everyone says 3. That's the right answer. First field is an integer. Okay. Second field is a bag. And third field is a map. Okay. Just a mistake here. It should not be a colon. It should be a pound. Okay. Yes, Manish. It's inside a curly bracket. Right. So it's a tuple with 3 fields. First field is a integer. Second field is a bag. Third field is a map. The bag contains how many fields? How many tuples are there inside my bag? 3. Exactly. Right? So you are getting it. Everyone is on track. So if you are getting this structure, you are getting everything about pig's structure. So this is everything in pig. Alright? Okay. So let's stop for today. Right? So next week we will plan to finish pig and start with hive. Right? We will look at demo. So remember where we had the healthcare data where we wanted to encrypt the information. So we will be using the same logic. So what we had done there, we had written a mapper, reducer, we had written an utility class to encrypt the data. Right? So there was lots of code there. That same example we will now run through pig. And you will notice everything is happening in terms of just in a matter of 5 to 6 lines. Half dozen of pig Latin code will solve your issues, will solve your entire problems. Right? So we'll be looking at 2 examples in pig. First would be the healthcare data, where we would be encrypting the personal patient information. And the second example would be on the weather information, the weather data. So we will be finding maximum temperature, minimum temperature. We'll be finding hot days, cold days, right? Those kind of things we'll be doing using pig. Right? Just 1 or 2 examples would be enough for you to understand how pig works. Right? There is nothing much complicated. Right? Pig is simple. It's not complicated. Right? If you compare pig with pig with MapReduce, if you are able to understand how to write a Java MapReduce, pig is nothing in front of that. Right? Pig is very simple as compared to your Java. Alright guys, so let's stop for today. Right, so we are stopping at slide 31. Yes, Manish, you can definitely get away with pig and Python. Alright, so we'll stop for today guys. Have a good week ahead. Right, just a reminder, please fill in the survey feedback. Okay. Thank you, Manish. Right, thanks everyone. Okay, I'm available for the next 5 minutes or something. So if you have any question, I'm here.